Hey everyone, and welcome to this podcast episode for Quality of Care and Patient Safety. Today I'll be talking about root cause analysis, or RCA, one of the most important tools used in healthcare to identify and correct underlying causes of errors or near misses. Instead of just asking who messed up, RCA asks why did this happen and how can we prevent it from happening again. To explore this, I sat down with David Devine, who worked for over 10 years as a medical technologist and later as the administrative director of laboratory services at Tampa General Hospital, one of Florida's top hospitals. He's seen everything: equipment failures, unexpected errors, and the day-to-day decisions that affect patient outcomes. In our conversation, Dave shared stories that show what root cause analysis look like in real life, from tracing a faulty reagent that affected lab results to redesigning policies that improved safety. Let's start with Dave explaining what his role involved and how his team made sure lab operations ran safely and effectively. What's your name and what did you do for your job?
My name's Dave Devine, and for 50 years I was a medical technologist and worked at various hospitals until I finally ended up supervising as the director of the laboratory at Lakeland Hospital and then at Tampa General Hospital in Tampa, Florida, a 1,000-bed hospital.
And what did that job entail primarily?
Well, I was in charge of making sure that the lab, the clinical lab, ran perfectly. So it had to be up 24/7 and put out excellent results at all times. And so I was in charge of hiring the people to work in the lab and then writing procedures and policies and making sure that all the safety rules were followed and making sure we put out the best possible result we could.
And how did you make sure you were getting the best possible result? What safety precautions and measures did you take?
The safety precautions were mostly involved with meeting the OSHA requirements because we did have a lot of chemicals and radiological material. And so for those kind of things, we had to follow strict guidelines from OSHA and other safety organizations. And then to be a qualified laboratory, you had to follow all the structure of the ASCP, the American Society of Clinical Pathologists. And so all of those requirements made sure that everybody in the lab was well-educated, competent, certified to work in a lab. And once you did that, you were pretty much assured of putting out good results at all times.
What you just heard was a perfect example of how labs are already built around prevention. Dave mentioned OSHA, ASCP standards, and constant staff training, all of which act as a proactive RCA measures. But even with these systems in place, things can still go wrong, and that's where the real work of root cause analysis comes in. Dave told a story about one of the worst issues his lab ever faced, a new analyzer that suddenly started producing inaccurate results.
But the final thing that made sure that everything was perfect was you had to make sure they had the equipment as well as the knowledge to perform with excellent results as a result.
Now, with all those things in place, were there still times where something went wrong?
Oh, God, yes. And there were a million opportunities for things to go terribly wrong. I think in all the years where I was the director of the lab, the worst thing that ever happened to me as a thing that went wrong was we were changing over our chemistry lab and putting in brand new machines. We've never had the machines that we were installing before. And so you do all the testing before you ever come live with the machines, and you're pretty much assured that everything is going to work right and that the results you put out are going to be comparable to the results that went out in the past. But there was one test, just one, that while we ran the tests and we were assured that everything was going to work right, when the reagents came and we put them on the machine, it did not work right. And so it was a bad batch, but it took us a while, a couple of weeks before we really realized how bad the problem was. And that was it was an embarrassment for me because obviously I signed off on everything and said the machines were going to work great. And it did look like they were going to, but that's where you just have to keep a close eye on everything at all times. And it took us a while to figure out Was it the machine? Was it the reagents? Was it the technologists? Were they doing something different at different times? And so you have to investigate and find out, and then you got to fix it quickly.
How'd you go about that investigation to figure out what the cause was? And was there just one cause, or was it multiple factors?
Yeah, the one cause was the reagents. That Abbott Laboratory was a supplier. They made the machinery for this chemical analysis, and it was a beautiful machine, and it did, I'll bet, 40 different chemical tests. But the one test that was so important to this one doctor who was doing parathyroid hormone surgery, and the test that we were running determined whether the surgery was a success. And so he went strictly by the results coming off of our machines to monitor his patients and how well they were doing. And the results that we were giving him weren't matching what he was seeing in the patients. The patients looked good, his surgery seemed successful, and yet some of the results he was getting would indicate that he didn't get all the tissue out that he was supposed to get. And so, it became apparent right away within a few days that we were starting to see some results that we couldn't believe. And so what we did is we started to run the same test on the new machine and the old machines that we were retiring. And what we found was the old machines were steadily putting out the accurate results, and the new machines were not. So it just took us that amount of time, and then we just switched back to the old machine, and we said, we're just never going to go with the new machine for that particular test.
That's a textbook example of an RCA in action. First, they defined the event, bad results from a new analyzer. Then they collected the data, comparing results from the old and new machines. Then they identified the root cause, a faulty reagent batch from the manufacturer. Finally, they implemented a corrective action by switching back to the old machine and updating their supplier protocols. RCA isn't about blame, but it's about the understanding of how systems fail and fixing them so it doesn't happen again. Dave explained why catching these issues early can literally save lives.
And so, you make adjustments, and that's what you have to do.
And if you didn't catch the errors that were happening, what would the consequences have been?
Yeah, now that's a real problem. I mean, if you put out a bad result, say a patient comes in for a PSA, a prostatic specific antigen test, which is a test to determine whether you think a patient has prostate cancer or not. Well, if you screw that test up and put out a bad result, you could end up costing a patient his life, because you're really saying, does he have cancer or not? It's a screening test. I know that. Everybody knows it, but they rely on it to give you an indication of whether they want to go ahead and do some biopsies, and then have the pathologist look at those biopsies and determine, oh yeah, there's cancer there.
And you can catch something early.
Yeah. And for me, I mean, it's real personal for me, because I've had my prostate out with prostate cancer, and my PSA initially was 3.2, went to 3.6, 3.8, and then all of a sudden it jumped to 6.8. And so 6 months, you go from 3.8 to 6.8, you go, what's going on? So I had the 12 biopsies they're needle biopsies of your prostate, and on one little segment, I had cancer. So they sent it off from our hospital to Johns Hopkins to an expert. And he said, yep, it is, it's cancer. And yet, when they did the surgery, all my cancer was within the capsule of the prostate. It hadn't gone out, got into my bladder or guts or anything like that. It was all in the prostate. So when they removed it, I was cancer-free.
What stands out in this story is how many layers there are between an error and a patient outcome. If just one layer fails, like a reagent, a technologist, or a review process, the mistake can slip through. That's why the Swiss cheese model in real life. Each layer of the defense has holes. But when these holes line up, that's when the harm reaches the patient. Dave also emphasized the human side of lab work, the training, the vigilance, and the sense of responsibility every technologist carries.
I was cancer-free. But when the pathologist looked at the slides, they said 50% of my prostate had cancer.
Wow.
So that one little biopsy just barely nipped the side of the prostate where the cancer was. So for me, it's real personal, and that, to me, is just indicative of the fact that every single lab test is so important. Mm-hmm. And that's why we were a teaching hospital at Tampa General Hospital, and we taught students to become laboratory technologists. And they not only did the book learning phase, where we went over all the information, but then we had them work side by side. Every day they'd go in the morning and do the book phase, and then in the afternoons they would work side by side with a medical technologist. Mm-hmm. And so that made them really well-functioning techs. From the minute they got out of our lab school, they could go and work in our lab or most any other lab, because they were well-trained on not only the knowledge, but the proficiency of doing the actual work and putting out a quality result. And so every year I got a chance right at the start of their school year to go and give a talk to them and tell them, this is how important the results are that you're going to be putting out. And for me, that was the biggest part of my job, is to make sure that every single student that came in was going to really be a good student and was going to be a good medical technology at the end of the course. And we never had a student drop out.
Root cause analysis doesn't end once you fix a problem. It's an ongoing cycle. Dave's story about rewriting procedures after incidents shows how labs use RCA to drive continuous quality improvement. Every policy is reviewed, revised, and reinforced over time. It's the same idea as the plan, do, study, act cycle we've discussed in this class. Plan the fix, do it, study the results, and act to make it permanent.
But I'll tell you, when the first 12-channel analyzer came out, everybody in the lab went, "You're kidding me." Mm-hmm. I mean, this is going to run, it's going to sample there and send it to 12 different little tubes going here and there, and they're going to read by different wavelengths of spectrophotometers, and you see the little wheel turning to put the right filter in to read the thing, and you're going, yeah, well, that ain't going to work. But it did. And so now you've got analyzers that run 32, 64 channels. I mean, these things that, if you walked into a clinical lab, and I don't care if it's Tampa General or if you go to Quest or LabCorp, the bigger labs, you just walk in and you go, holy cow. This, like, to most people, it looks like it's science fiction. Mm-hmm. Because it is so automated, and you just see all these machines going about doing all this stuff. And there's a few people in there, I mean, loading the test tubes or putting things on, but the rest of it, it's all behind the scenes. Once every shift, our people had to come in, restock the reagents, make sure everything was in there so your test would run, and make sure the analyzer could do its job. But once they set it up and it's going, until you hear an alarm or you sense that something might not be right, it's all on its own.
So with these new technologies and advancements, you're relying less on human factors being an error, and now it's just keeping up with the equipment maintenance-wise to make sure they run.
Yeah. I'll give you a good example. I mean, when I first started in the lab, actually, I worked in the lab when I was still in the Navy. And so, I was started in 68. And so 72, I got out and said, gee, the labs are getting so much better, and the analysis and the analyzers so much better. It was fascinating. So in the Navy, what we were taught to do, to run a routine glucose, is you had a reagent, and then you had a couple of bottles over here of the reacting things that would make the reaction happen. So you would line up, say, 20 test tubes, and you'd put a little sample of the serum from every person in those test tubes and mark them appropriately. And then you'd set the clock, and you go click, and you'd add the reagent every 15 seconds. And you added the reagent and had to mix the tube, twist it, like take it with your finger. So you're mixing it, and then you go to the next one. Put a little more, put the right amount in each one. So now you got the substrate that it's going to work on, and you got the sample. And as it processes, then you go and you time it out, and when you come back around, you go, oh, I want to stop that reaction to see how much glucose was in there. So you put in another little drop of a reagent, and it stops it, and you got to stop each one exactly on time. And then, now, you take that thing, that tube, and you take it out, and you got to clean it out, make sure there's no fingerprints or anything else, put it in the spectrophotometer, make sure that's on the right wavelength to read it, because it's a color reaction. The more intense color, the higher the glucose. And so you read that, and then you look at a chart and you go, okay, it reads 74, and 74 is equivalent to good, 110. He's normal. Yeah, that was, and we did 20 analysis, and what does it take? It took like an hour,
There's so many things that can go wrong with
yeah.
that. Miscounting the time, fingerprints.
Absolutely. No, and I mean, that you could do as many as you could do, and then what did you do? You set up another rack of test tubes and start it over.
And nowadays, it's just all machines.
All machines. Yeah.
And you're just testing it, and you can do like control testing with machines to make sure it's still running properly.
Absolutely. And see, that's your key right there. If you want to know if your analyzer's running right, you put known samples on, like every 10th sample, every 20, it depends on what test you're running. But that gives you the key right there. When the test starts to come off, you look at those samples that are your knowns and say, oh, my controls are in for that whole batch. Boom, you put out those results. But you never go boink and say, take the results until you look at the control samples, always. And to make sure that this machine is set up right to before you even test the samples, you run standards. So you say, okay, here's my 60, here's my 80, here's my 100, 120, here's my 200, whatever. And so the machine calibrates itself to those samples, and that's how you know when you put in your test sample, the known sample, the control one, boom, it comes out right, you set it up right. Yeah.
Perfect.
Every analyzer. And that's where the human factor comes in, You got to have people knowing what they're doing to set it up right and make sure it runs right.
Yep.
You rely on the training, and you rely on your policies and procedures. And if it says don't do this or do this,
you're constantly updating those policies and procedures.
There's a good example. Yeah, and you are. And it doesn't matter whether it's a new machine that you're writing a new policy for, or a new something that you're going through to screen your employees, or to document that they're qualified. It's an ongoing process, always. Every year you go over every single regulation, single safety procedure, and then every 2 years, OSHA came in and looked at our lab for safety. And so, it's that thing where you're constantly thinking, okay, we're getting closer to that time for the next inspection, and so we better have everything perfect.
And you want to have multiple safety features or precautions in place, because you don't want to have a one fault. Like if one thing goes wrong, then everything happens.
Yeah, and see, it's real difficult too, because you have to pick a team from your own hospital to go and inspect other hospitals. So because who knows how a hospital lab's supposed to be run better than a hospital lab? So as the lab director, I would always consult with the pathologist, and we'd decide, okay, and usually it was supervisors, but sometimes it wasn't. It was medical technologists working the bench because the supervisor maybe wasn't there or was on vacation or whatever. So sometimes you would take along, say, a histologist, somebody processing the tissue that wasn't really the supervisor of the histology lab, but just another tech. But you'd rely on them to look at that section of the lab and say, boy, I looked at their slides and their processing is not good. Or they're cutting the tissue and their microtomes are not slicing the tissue, they're not laying them out, they're not flat. I looked at the tissues, there were ripples. And if you're looking at a slide and you've got these ripples and things in it, how can you really tell if that's cancer or not? So every step of the way, you got to rely on the people to do the best they can, even if it's your own self-inspection, which we would do before the real inspection, because we wanted to know if anybody thought, hey, we've fallen down on this particular area, you need to rewrite that procedure. It's not clear, whatever.
Now, in the lab, you said you had like multiple backup equipment and processors.
Oh, yeah.
Or is there any point that there was a single point of failure that if something went down or broke, then that would halt the process? So, for example, in a surgical room, if the central oxygen line stopped, then that could stop the procedure. You need to figure out what to do. There's not an immediate like backup generator. Is there any single point of failure
that would have
exists?
been the only thing that could have stopped us, is that we do, because the machines had to be cooled, they had water running. So you had to have water and you had to have electric. But for us in particular, we had backups all the way. And I don't know, you might have even seen it when that last hurricane came through last year. All of our stuff that kept the hospital running, the generators and all that, were in the basement of the hospital building. And so they were concerned about it, and they built those doors that were like submarine doors that when you closed them, they sealed completely. And actually the water came up like 8 feet on the 12-foot doors.
Wow.
And they did not leak.
So you're building in these preventions to prevent a single point of failure.
Yeah. Yep.
You can't have that process stop.
No. Got to keep going. And it was a concern too, because we had backup contingencies. Now this wasn't my department, of course, but we had backup contingencies for if there was an ultimate failure, like a complete failure of everything. How do we evacuate? How do we get? Because Tampa General Hospital is on an island, so you got a bridge that you can cross over, but crossing over the bridge just gets you to the mainland, which might be underwater as well. So we had, for the hospital, they had backup plans with helicopters, boats, and stuff to get all the patients, to safety.
And these are all relationships you have with the helicopters and everything in advance, so that if the scenario did happen, it's immediate what's going to happen.
Yeah.
Something that really stood out in our conversation was Dave's honesty about leadership challenges. He talked about administrative decisions that sometimes clash with safety priorities and how hard it can be to balance quality with cost. This is an important reminder of how RCA doesn't just identify technical failures, it uncovers organizational ones, like staffing shortages, poor communication, or inadequate leadership support. And those are often the hardest to fix.
You had to have it do accurate results. It had to be accurate, and it had to be fast, and it had to be multi-sample, multi-analyzer test, multi-test analyst. Yeah. And so, and then lastly, and of course, most importantly to my vice president, it had to be cost effective. I mean, every year that was the big challenge, is here's your budget. You got so much for people, so much for equipment to buy new stuff, and so much for reagents to run the tests on that equipment. And so one thing that I did, and I felt like there weren't many people doing it, but I always insisted with the vendors. I said, look, I need guarantees, 2 guarantees. I need a guarantee that this is going to work as you say it will in our system. And if it doesn't, if it fails, if you don't support this equipment, I want out of the contract. In other words, maybe you decide, we're not going to do those reagents anymore. Or we're not going to support that test. Well, if that's a test I need, then it voids it. But it's funny that way. No matter how much you care about your lab and what you're doing, there's somebody on the upper levels who has no idea what you're really about, and how dedicated you have to be to put out good results. They don't really, all they see is a bottom line. They're told by the CEO or the CFO, here's your budget, make it happen. But that's the problem for me, is I always felt like I was giving them the best I could under the circumstances with the budget I was giving them, and had kept the cost very effective for the lab, but it didn't mean anything to them. They had their own ideas.
Well, thank you so much.
Yeah, my pleasure.
Hearing from Dave Devine really brings root cause analysis to life. It's one thing to learn RCA as a step-by-step method in class, but it's another to see how it plays out in a high-pressure environment like a hospital lab, where every result affects real patients. RCA is about accountability, but it's also about learning. It asked what system allowed this to happen instead of who's at fault. Dave summed it up best when he said, "You have to keep a close eye on everything at all times, because one missed detail can change a patient's life." I want to thank Dave for sharing his stories and experiences, and thank you all for listening to this episode on root cause analysis for quality of care and patient safety.